Hello students, how are you? Hope you are all in the pink of health. I am Atun Roy and you are watching Bond Making and Bond Breaking channel. Today we will discuss about very important topic, that is coordination compound. Uh, we'll, we will talk about the coordination compound, the ligand, the central metal atom, the formation of coordination compound, and as well as we will learn about the UPAC nomenclature of the coordination compound, as well as we will learn about VBT, that is valence bond theory, and CFT, crystal field theory. Okay, so first topic is that what is coordination compound. First one is, what is coordination compounds? So those compounds are called coordination compound who can connect with each other with the help of coordinating bond. What I have said, I have said that a compound is called coordinate compound. A compound is called coordinate compound when the atoms, the constituent atoms, are attached to each other with the help of a beautiful coordinate bond. So now we have to learn what is coordinate bond. Okay, so first is, we can classify the chemical bond into three categories mainly. Suppose one is a covalent compound. So what is covalent compound? Covalent compound is depending upon the sharing electron. What do you mean by sharing electron? Suppose A is an element and B is also an element. So if A share electron and B also share electron to form the bond between A and V, at that time a bond is formed. That bond is called covalent bond. Okay, and the second one is when a atom wants to lose its electron from the outermost shell, and other element will want that electron to accept the electron and form the anion. One is formed cation due to loss its electron from the outermost shell, and one is formed anion due to the gain of electron on the outermost shell. For that reason, a bond will occur, and that bond is called ionic bond. So number one bond is formed due to the shared electron with each other, and the second will form due to the formation of cation and anion, and third one is that there is a element A and another element B. So B is the acceptor of electron and A is the donor of electron. Is there any possibility to form a bond? Yes, there is a possibility to form a bond. That bond is called coordinate bond. So today we'll learn about this coordinate bond. So what is coordinate bond, and what are the coordination compounds? So number one is that the salt can be divided into two categories. One is double salt and another is coordinate salt. 100% ionization, 100% dissociation is possible in the case of double salt. And on the other hand, for coordination compound, we can see that 100% dissociation is possible only the outside of the coordination sphere, and with the coordination sphere and the outside of the coordination sphere, but it is not possible to break, to decompose, dissociate. It is possible only in the it is not possible only in the coordination sphere. So this is the vital point about the coordination compound. So salt can be classified into two categories. One is double salt, another is coordinate salt. In the case of double salt, we can classify, we can ionize 100%, but for the case of coordination compound, we can't break the elements in the coordination sphere. So now we have to learn something. I have written it, I have given an example, that is K4FeCN whole 6. CN whole 6. So you will be glad to know that it is a very good, well-known, popular coordination compound. So here this sphere is called coordination sphere. Okay, this sphere is called coordination sphere, and this sphere is called ionization sphere. So this is called coordination sphere, as well as it is called ionization sphere. Now this Fe, you know that Fe belongs to D group elements, that means D block elements. So what is called D block elements, and which elements are known as D block elements? So the elements can be classified into 4 blocks. One is S blocks, that means last electron entered in the S subcell. Another is P block, last electron enters in the P subcell, and D block means last electron will enter in the last cell of D. Now D block elements has a characteristic, is that it has vacant d orbital. That means maybe partially fielded or half fielded, the vacant d orbital. So those elements are called D block element in the ground state or in the excited state. If it has vacant d orbital, at that time that element is called D block element. So Fe has vacant d orbital. If I say Fe, what is the atomic number of Fe? That is 26. If we write its electronic configuration, what we will see that 4s2 and 3d6 is the electronic configuration. So the last electron enters in the D subcell, and it follows one rule, that is n(s)2 n-1 d 1 to 10, this formula. That's why Fe is called D block element. Now Fe has a D block, Fe has vacant d orbital. So what is the tendency of Fe? What is the tendency of Fe? The tendency of Fe is that to collect the lone pair, to collect the electron, to collect the negative charge from the ligand. So now if we ionized it, K4, it formed 4K plus, as well as it is also formed Fe, and then Cn, then whole 6 and 4 minus. So Fe is a central metal atom and Cn are the ligand. So what are the role of the ligand? To donate electron or negative charge to the central metal atom, that is Fe here, and the ligands are Cn here. So we can define various terms through this compound. One is what is ligand. Ligand means who donates electron or negative charge, okay, to the central metal atom is known ligand. Now which can be called the central metal atom. Central metal atom is that element who can accept electron from the ligand. So Fe can be called central metal atom. So as it accepts electron from the ligand, it can be called Lewis acid, or it acts as Lewis acid. And ligand donate its electron at that time. At that case, it acts as Lewis base, as it is donate its electron or lone pair or negative charge. It can be called Lewis base, and if we accept its electron, so if it can be called the Lewis acid. Now, ionization is possible only the coordination sphere and ionosphere in between. Not it is possible in between the ionization spheres element. That means the ionization is not possible between the ligand and the central metal atom. It's the fact. Okay, I think you will learn about the coordination compounds and its structure. Now, can we tell its name also? Can we tell its name also? So for this case, you have to learn some rule. That is, 6 is called a hexa. That means penta, hexa, buta. That means hexa. And CN is called cyanido. Cyanide theke ide theke ido. So CN is called cyanido, hexacyanido. Then ferric is converted into the ferret. So hexacyanidoferrate. But at the beginning we can write potassium hexacyanidoferrate. Potassium hexacyanidoferrate. At the end of the ferrate, you have to give a bracket and write its oxidation state. What is this? What is oxidation state? So we can calculate. We know the total charge of this element will 0. So we have to find out the oxidation state of the central metal atom, that is X, and we know the oxidation state of K, that is plus 1. Why? Because K belongs to the group 1 element. So what is the oxidation state of group 1 element is plus 1. So for that case it is considered as plus 1. So plus 1, 4 plus 1. So 4 plus 1 we get plus 4, as well as we get plus X, and Cn we know that the minus 1 minus 1 6 minus 6, so it is minus 6. In totally the charge will 0, because compound never be charged compound. So compound should be neutral. So the total charge of this compound will 0, and for this reason we can calculate the value of X and we get 2. Right? We get 2. So what is the name of this compound is hexacyanidoferrate. But at the beginning potassium, for that reason. So potassium hexacyanidoferrate, and the value of X in the bracket, that is 2. That means 2. Potassium hexacyanidoferrate 2. Now we have considered, we have taken another example, that is K2ZnOH whole 4. This is also a good example for coordination compound. What is the name of this beautiful coordinating compounds? The name is that potassium for the K2, potassium for the K4. It's not matter here is 2 or 4. So the matter is that is potassium. Okay. So potassium, and for the 4 we can say for 4 it is tetra, and for OH it is hydroxido. So what we have got? We have got that potassium tetrahydroxido, and for zinc is converted into zincate. So what will the name? That is potassium tetrahydroxido zincate. Okay, potassium tetrahydroxido zincate. Now what is the Roman? What will be the number in the bracket? What is the oxidation state of the zinc? Now we can calculate easily. This is 4, this is minus 4 plus 2. That means the value of zinc will 2. I hope you will learn. But now what will be the final answer? Final answer for the ubique nomenclature of coordinating compound, that is potassium tetrahydroxido zincate. Potassium tetrahydroxido zincate bracket give the oxidation state, that is 2. So in this way you can calculate, you can give the name of any coordinating compound. But here is also different, because here ionization sphere is positive and the coordination sphere is negative. But for the case where the coordinating sphere will positive and the ionization sphere will negative, for that case we have to remember some exceptional case. That is, we have taken such example as silver, ammonia, and this is chloride. Silver, ammonia, and chloride. Okay. Now, if we ionized it, what we have got? We have got that AgNH3 whole 2 and it forms Cl minus, so it is plus. For K4 FeCN whole 6, for K4 FeCN whole 6, what we have got? We have got 4K plus and FeCN whole 6. This is the minus 4 minus. Okay. In this case, this sphere is negative sphere, and in this case, this sphere is positive sphere. So the name will change. For this case, potassium. This case name will potassium hexacyanidopherrate in the bracket oxidation state. But for this negative sphere, this is negative sphere, and for this positive sphere, we get the name like this. Diamino, not argentate. For this reason, the name will diamino silver, not argentate, silver in the bracket the oxidation state, then chloride. Listen to me again. Diamino silver bracket the oxidation state, and then chloride. Okay, this is the basic fundamental concept for the naming of the coordination compound. Here also very important examples to give its name. Okay, suppose we have such example, platinum Pt, then NH3 whole 4, and on the other hand here platinum Cl4. This is the coordination sphere. Here you can see one positive sphere and another negative sphere. One positive sphere and another is negative sphere. For this reason, this Pt is act as platinum and this Pt act as platinate. So what will be the name? The name will tetraamino platinum bracket, then tetrachlorido platinate bracket. Total charge, this is X 0 because neutral ligand. NH3 H2O and NO. Those are neutral ligand, charge will 0. Platinum X minus 1, so total charge X 2X 0 and 4 minus 4, that is equal to 0. The value of X equal to 2, so I get 2. So name is tetraamino platinum 2 tetrachlorido platinate 2. In this way we can give the name of the coordinating compound. Okay, so thank you so much for listening, for learning such a beautiful topic, and the next day we will proceed this chapter. So don't worry, coordinating compound, coordinating chapter and coordinating bonds are very easy, on the basis of 12 board exam. So don't worry, learn it and absorb the marks which will be given for your or on your boards paper. So don't worry, be prepared, take care of your health, keep studying and keep smiling. Thank you.